VIZZY Devlog number 4, let's go! We've got a robotic arm. Isn't that amazing? This is number 4, by the way. This one's a little different. It has the same inverse kinematics as before, and it actually has, instead of the head being with PCI, it's now being mathematically calculated. So if there's a massive load on the end, and it just so happens that your end effector is being like rotated down 45 degrees, it's going to go directly up now, which is great. And also, another thing I improved is I managed to get the crossover between the borders a little bit smooth. It used to shake quite a bit. And this one can go much faster because it has half the range, which is a bummer for some people, but I think that's perfectly acceptable because the magnets in this game are just insane. You can still use this for a base, and it's actually much easier to use because now when you rotate the head, it actually rotates on this point. It doesn't rotate here anymore. It does the maths to calculate that, which is really cool. As you can see, the speed constant, that's pretty obvious. You double that, it's going to make it go twice as fast. Up here on the left, you're going to have the initial position. Pretty simple. You will also notice I'm using a lot more custom stuff now. It's a very compressed code. I don't think I can get it any better. Another thing here is we have the rotator inputs. These are pretty basic. This one's going to be the very first rotator, the one that moves it all around. This one's going to be the one that points it up to the target. This one is going to be the elbow, it moves it in and out like a scissor motion. And then we have right here, we have this one that cancels out it, and it also makes it bend into a straight wrist. Then we have rotator 5, and that is going to be your, which is great. Down here, we have this very large clump of custom inputs. I'll go through this. Okay, so the base part number, that is going to be the reference for the base of the robotic arm. So if I rotate that, it's going to rotate the entire grid, so-called, of mass with that. So probably don't touch that. Then we also have the head, and now it does calculations from the base to the head of the arm to get the inverse kinematics. So I recommend not changing this. However, another thing that you definitely can change is the vector head return. This is going to be the position offset from the head that it will actually rotate in 3D space around. So I have this at 0.55 right now, so that if I rotate, it's going to rotate around the fingertips of the robotic arm. And then we also have the displacement, so basically if it gets longer than this amount, it's just going to set it to this amount. That's just making sure that it doesn't actually go extending past what it can do and then freak out. Okay, so we have a Rodriguez rotation formula down here. That is to do the mathematical calculations of the rotation of the arm. Right here we have the other Rodriguez formula thing, which is just going off this, so it's inception. We have the Z theta, that's the plane of the position. Makes sense. So it's the very first rotator that's trying to find the position of that. Go over here, we have this loop, and so pretty much if it goes too far, if theta is a really large number and it goes to a really small number, or the other way around, a really small number goes to a really large number. The issue with that is it's going to actually make the rotator spin all the way back around. We don't want that. So instead, I just add 1. Right over here we have the toggle. So if activation group 1 is on, it's going to move the arm when you press all your like WASD, Q and E. However, when activation group 2 is active, it's going to rotate the arm instead. So pretty much that is all my code. That's all it does. Speed constant here, change this if you really want a faster arm. I recommend not changing it. One thing you will notice while I'm demoing this is that it's going to be a little bit jerky. That is sadly due to the fact that I'm recording, so please take this with a grain of salt. It is much better if you are hitting maximum number of frames and you're not on a very laggy device like what I am. So as you can see, we do have that inverse kinematics working. I can toggle 2, so now I can rotate the head up and over. Then I can use Q and E to rotate around. And then also if I want to roll, I can definitely do that. I can roll. So then now if I go back to translation and I press W, it's going to move that way. Isn't that interesting? Now I'm going to go back to rotation, roll it back over. 1, go up. See, look how cool that is. I can see this definitely being useful for if you're building a base on, let's say, Siluro, or I don't know, Briger or something. Some strange place that you can go to. So basically, it should make docking while on the ground much easier. However, I don't recommend actually lifting stuff with this because it is a 500 kilogram arm, and the rotators in this game are not very strong. So I'd say the maximum load you'd want to do would be around 100 kilograms, which is very poor. If you want to push it, you can maybe do a ton, but I don't think that would work very well, and it would definitely be flexing a ton. Get it? Eh. Thank you for watching, and I can't wait to see you guys in the next one that I make.